everyone. Welcome to your Algebra I PlayPosit for the week. This lesson is going to be covering 3.02 in your OMHS. This is our graphing unit. I'm so excited to get to this unit in our lessons. Make sure you go ahead and grab your notes, whether you printed those from the ones I provided or you have your own notebook paper. Make sure you have your OMHS PlayPosit graded assignment open and ready to go. Get my pen, there we go. Just a few reminders before we get started. You guys probably saw this in a few different places, but this week is Science Week. We have different events going on every single day that are optional for you guys to join in on. And you'll see that today at 1 o'clock, you can make some tessellations with two of our 8th grade math teachers, Ms. Popko and Ms. Dorito. If you want to participate in the actual tessellation creation, they ask that you have these materials available. And most of these things you probably have already in your supplies. A square piece of paper, index cards work really well, some scissors, some tape, some paper. A4 size, that's like general size paper, 8.5 by 11. Pencil markers, color paper, or color pencils and crayons. So that's going to be a lot of fun. And then on Tuesday, you have Autumn Nature Poetry with Miss Robertson and Miss Jenkins, two of our ELA teachers. Wednesday, Women in Science with Miss Cedar and Miss Wayman. And then Thursday is a session with me. We're going to do a dancing rice experiment, and we're going to see how science and math are related and different things that cause exponential growth. So you guys, if you want to participate in the experiment part of this, again, hopefully you have a lot of these things around the house. And if not, maybe it could be an easy trip to the store, but they're definitely not required. But for the dancing rice experiment, you'll need white vinegar, baking soda, instant rice. So it must be instant rice. It won't work if it's regular. A clear jar or just a glass, some water, and some food coloring that's optional. So for any of these sessions, you don't have to participate in the activity. You can still come, you'll still have fun, you'll still learn a lot. But if you do want to participate in the activity that's going to be happening, then you'll want to make sure you have those supplies on hand. It doesn't look like, oh, the Tuesday session says, gather some inspiration on a nature walk from a magazine or the internet and bring it with you to the session. And then I don't believe Wednesday has any materials, no. Friday, you guys know, is our most loved pet parade with our staff. So I hope to see you guys all there. I know that the 8th grade is at 1 o'clock and 7th grade is at 11 o'clock. These are all on your Class Connect schedule for you to click through. Got a lot of fun things planned for next week. Here's that pet parade information again. So again, 7th grade's at 11 and 8th grade's at 1. So excited. All right, another quick reminder that our first end date is approaching. We still have plenty of time, but it is happening in 3 weeks. November 6th is your first end date. After this date, you will no longer have access to retake any graded assignments that were assigned from the beginning of the year until this date. So my recommendation now is to do a little bit of planning, right? Make sure that you complete any assignments that might have zeros for some reason. Make sure that you review and retake any low graded assignments. And of course, as always, if you need any help or you have questions about this process, please send me an email. This is your first end date that you've experienced this year. So that's why I wanted to make sure we talked about it well before it came. After this date, you will no longer have access to any of those assignments to retake or to complete. So the goal will be to have them done before this date. Don't forget about our Desmos online calculator, that you're going to want to have. It is the graphing version of the Virginia State calculator. I know you're probably tired of seeing this in your videos, but I just want to keep reminding people that we are using the Desmos calculator. It is free. It is accessible via this link. You can certainly, I know you can't click on this now, but you can definitely Google Desmos Virginia Graphing Calculator. You can also access the link from our online class. There's a folder that has it in there. All right, so today we're going to basically be working towards a lot of what algebra is about. We're going to recall parts of a graph, finding some intercepts and slope, and then of course, step 3. And these items that we're going to get through today are going to work us towards being able to model real-world linear equations. So if you participated in the extra credit, you guys provided me some real-world equations mathematically and expressions that represented some things in your lives. I loved them, and we're going to share some of those in class tomorrow. But what we're getting to now is modeling real-world linear functions and doing them on graphs. So it's going to get even cooler. All right, here's our flashback for the day. Remember, this is a recording, so you can pause this at any time, try this on your own, and then click play to check your answer. So our goal is to solve for x. I see tons of x's in here. Lots of them. 1, 2, 3, 4. So before we can solve for x, we have to get all the like terms together. So let's just start doing some of this math here. When you have a number in front of a parentheses, remember you distribute. So 2 times x is 2x. And oh, do you guys see what just happened? Well, this should be interesting. Let's look at it both ways. We should distribute, but also since these are parentheses, you could combine them first. So let's do it both ways and see if we get the same answer. 2 times 3x is 6x. Now the right-hand side, we can do the distributing again if you want to. Over here on the right, I'm going to show you what happens if we combine the parentheses first. So we have negative x times 2 is negative 2x. Negative x times negative 3 is a positive 3x plus 2. All right, now let's combine like terms. So 2x plus 6x is 8x. Negative 2 plus 3 is plus 1. Okay, let's keep going. I could have done these, huh? 4 plus 2 is 6. Now, real quick, before we go any further, let's see what would happen if we combined the parentheses first. So x plus 3x is 4x. I mean, ideally, that's what we would do, right? Because we're thinking of PEMDAS, so parentheses first. And because those are like terms, then we are able to combine them first. 2 minus 3 is negative 1. All right, now 2 times 4 is 8x. Negative x times negative 1 is a positive x. Ooh, do you guys see when we compare the two, we end up with 8x and x. Sure enough, 8x and x. So you can do it either way. And really, the only reason this works, honestly, is because the items inside the parentheses are like terms. So you're able to do that. Pretty cool to see that there's 2 different ways there. Okay, over here, you know what? I forgot my little x on the 2. So that's definitely going to change this. Should not be a 6, right? And hopefully you caught that as well. We're just working through our problem here. So let's combine these like terms. I'll just write it down one more line. So that's going to be 4 plus 3x. Okay, now let's get the x's on the left and the numbers on the right. So the inverse of plus is minus. I'm going to do this, okay, I was going to do it in 2 steps. Let's do it in, so 8 minus 3 is 5. And now we'll subtract the 4. And you end up with 5x equals 0. So we'll divide by 5 on both sides. And x is 0. You don't see that too often, do you? Remember, with these kinds of problems, you can always check your work. So let's take the 0, we'll plug it back into the original equation and see if it's true. So instead of x, we're going to write 0. Two times 0. Okay, now let's just work it through. Well, 3 times 0 is 0, right? 0 plus 0 is 0. 2 times 0 is 0. So the left-hand side is a 4. The right-hand side, remember anything times 0 is 0. So that term will go away, that term will go away, and we're left with 4. Sure enough, it works. That's work. So we can always check our work. All right, so here's our warm-up. Now, while we haven't done this type of question yet, I know that you guys can do it. We've talked about ordered pairs already. And remember, an ordered pair is an x, y coordinate point. The x comes first and the y comes second, just like in the alphabet. And when a question asks something like this, which ordered pair is a solution, it means that the pair that you plug in is going to work. It's going to make sense. So we could take each of these, plug them into our linear equation, and see if it's true or false. So the one thing here to keep in mind is that x is first and y is second. That's definitely going to change your answer if you mix those up. So instead of x, I'm going to write 11, and instead of y, I'm going to write 1. And let's see which one of these is true. Because if it's a solution, that means it's true. The equation would be true. So we get 22 plus 3 equals 16. Well, hopefully you can already see this is not going to be true, right? 22 is bigger than 16 already. So you would get 25 equals 16, and that's not true. It's not A. Let's try B. We're going to plug in 3 for x this time and 2 for y. So we get 6 plus 6 equals 16. Well, that's not true. 6 plus 6 is 12. All right, let's try C. This is A, this is B, this is C. So we're going to plug in 5 for x and 2 for y. All right, 2 times 5 is 10. 3 times 2 is 6. Ooh, this is looking good. 16 equals 16. That is true. C is true. And meaning true, it means the left-hand side equals the right-hand side. It's always a good idea just to confirm. Let's try D. Why not? If you get the same answer for D, it could mean a few things. One, the quiz writer messed up, or maybe we messed up when we checked it on C, you know? So let's just work through it. 2 times 7 is 14. 3 times 2 is 6. Okay, so this is good. 20 does not equal 16, so D is also not true. We're going to learn a way to find this, I don't want to say more easily, but more quickly in the coming days using your calculator. So look forward to that. All right, so let's hear it. I know that we're not together live, but just think about this. What are some words you can use to describe these graphs? Maybe pause the recording, make some notes on your paper. There's really no wrong answer. I'm sure you guys can already automatically think of a few adjectives to describe these graphs. This first one, a lot of times people say it's going up, right? It's going up from left to right. That's something we hear a lot. What else could we say about this graph? We also hear things like, oh, it's crossing the x-axis at -5, and it's crossing the y-axis at +4. Those are two other really good pieces of information. There are arrows on the ends of the line, so that means it goes on forever, forever and ever. I think that's about it for us in this class, what I would say about this line. You could say that the graph lives in the first, second, and third quadrants. Something else kind of describes where it's living, where it's going through. How about this one over here? This line, a lot of people say, is going down from left to right. We read graphs just like we read books and just like we read equations from left to right, and it is going down. You could imagine yourself taking a walk on the graph, and you would be walking down the line. Similarly, this line has an intersect of 0, 0. It's going through the x-axis and the y-axis at 0, 0. It intersects right there. And this graph lives in quadrant 2 and quadrant 4. Cool. So let's review or learn how to find the intercepts graphically. So an intercept is just where the line crosses that axis. Remember, this is the x-axis and this is the y-axis. Remember how I remember? Remember how I remember? Do you guys remember what I said about drawing the y? You draw a really long y. And that helps me remember that the y-axis is the vertical axis up and down. It's a little trick or a tip. So the x-axis would be right, I'm sorry, the x-intercept would be right there. And sometimes it kind of depends how the question is asked, but you might see it written as x equals 3. It's more formal and more common and just better if you write the intercept as a coordinate point. So that coordinate point is 3, 0. We start here in the middle at the origin, go over 3, and that's it. We don't move anywhere else. Whoops, my pen went nuts. Let me erase that. If it'll let me. Nope, our eraser is being funny today. Weird. Okay, well, please disregard that weird line. So the x-intercept is right there at 3, 0. Our y-intercept is here at 0, 2. So the y-intercept is at 0, 2. So we are going to write our intercepts as coordinate points. Again, sometimes you might see it like this, but it's really not as accurate. I don't want you guys doing it. Please don't. Because sometimes it can mean other things. So we're going to write our intercepts as coordinate points. But I did want to point it out just in case you see it like that sometime in your life or in our lessons. All right, how about this graph over here? Remember, the intercept is where the graph crosses the axis. So here the x-intercept is right there at -3. So -3, 0 is the x-int. And here's the y-axis. Now, I didn't draw this graph very beautifully, did I? It's kind of challenging to grab it when it's not on a grid mark. But we could call that 2.5, right? I probably meant to put it at 2, but we can call it 2.5. Decimals are allowed. Decimals are actually more real world. So our y-intercept is going to be 0, 2.5. So what do you guys notice about the intercepts? So if you look at the x-intercepts, they have something in common. What do they have in common? They both have 0 for y. You see that? And the y-intercepts both have 0 for x. That makes sense, right? Because once you get to that point, you're not, like once we get to the point here for the y-intercept, we're not going to move anywhere else in the x direction. It lives on the axis. That's why x is 0. And the x-intercept lives on the axis. That's why y is 0. You don't move anywhere in the y direction. Here's some more examples. So if we look at this vertical line, the x-intercept is right here going through -3, 0. And this line does not cross the y-axis anywhere. So the y-intercept is none, does not exist. How about a horizontal line? Hopefully you can see it's going to sort of be the opposite, right? This does go through the y-axis here. Whoa, whoa, stop. No! Sorry. Man, I wish I could get rid of that. I don't know why that happened. I'll have to look into that. Recalibrate my pen. At 0, -2. And there is no x-intercept. That horizontal line is never going to cross the x-axis, ever. So we're just going to put in some notes here about x and y intercepts. So the x-intercept is where it crosses the x-axis, and that is the horizontal axis. It also occurs whenever y equals 0. Remember we saw that? That's because it crosses that x-axis and then it never moves in the y direction, ever. That's a pretty big deal. X-intercepts happen when y equals 0. All right, let's talk about y-intercepts. Hopefully your brain is sort of already thinking it's the opposite of what we just wrote. So these cross the y-axis, which is the vertical axis. And these occur whenever x equals 0. Again, because we don't move anywhere in the x direction, because it has to stay on that y-axis. Don't forget, if you need to pause the recording at any time, you can do so. That's kind of the beauty of the recording. So let's practice finding the x-intercepts algebraically. So we looked at how to find intercepts graphically, right? With the coordinate plane and the line and the picture. Now we're going to look how to do it with numbers and letters algebraically. Remember, we said on that last slide, an x-intercept exists when y equals 0. And a y-intercept exists when x equals 0. So we're going to use these definitions to help us through this. So this first one, let's find the x-intercept. So we're just going to plug in 0 for y. That's it. Algebraically, we know the x-intercept exists when y is 0, so let's plug in 0 for y and see what we get for x. So 0, we're going to solve for x. See, most things come back to solving. So let's move the 2 over. And we get 3x equals 0. We'll divide by 3. And in this case, we get x equals 0 as well. So the x-intercept is 0, 0. X is 0 and y is 0. What kind of line is this, you guys? If the x-intercept is 0, 0, that means it's going right through the origin, right through that middle point. And we're going to get to graphing soon, but just kind of you can kind of visualize that 0, 0 is right at the origin. So if it goes through 0, 0, that means there's no y-intercept. Well, it is 0, 0, right? Here, if a line goes through 0, woo, that's not 0, 0. Hey, that worked. Oop, there we go. So I just drew a line. If this one's positive, we'd have to figure out what this one be. This one is positive. So it's going through 0, 0. So the y-intercept and the x-intercept are both 0, 0. Crosses right there. So let's try this next one. We're going to find the x-intercept first by plugging in 0 for y. There we go. We get 0 equals 2x plus 10. So I'm just going to get x by itself by subtracting 10. And then we'll divide by 2. So you get x equals negative 5. So remember, we want to write the intercept as a coordinate point. So we have an x and a y. So the x-intercept is negative 5, 0. Be really careful here. Sometimes people will mix up the numbers when they write this point down here. They'll put 0 and negative 5, and that's not right. Remember, the x comes first. Okay, let's find the y-intercept. So remember, the y-int is when x is 0. So we're going to plug in 0 for x this time. I'm just going to do this other problem on another page. All right, 2 times 0 is 0. And we'll divide by 8. We get 10 over 8, which we know reduces, right? Because 2 goes into 10 5 times, and 2 goes into 8 4 times. So we can write that as 5/4. So remember, our coordinate point is going to be 0, 5/4. Because x is 0 and y is 5/4. So you want to write the intercepts as a coordinate point. So we have the x-intercept and the y-intercept. It's okay to have fractions. Fractions and decimals are actually more common in the real world, so it's good that they're there. Usually you're dealing with money or pounds or inches. Things are not always going to be whole numbers. Let's get this another one on another page because I guess I write big. So it was y equals 2x plus 6. All right, cool. Let's find the x-intercept. We're going to plug in 0 for y and see what we get for x. We'll subtract 6, get -6 equals 2x, and then we'll divide by 2. Yeah, I write huge when I have the space, I guess. X equals -3. So our x-intercept as a coordinate point is -3, 0. We have the x value that comes first, and we have the y value that comes second. Let's find the y-intercept. That's when x is 0. So let's plug in 0 for x and solve for y. Ooh, this one's fun. Y equals 6. We're done. So x is 0 and y is 6. So that is our y-intercept. Excuse me, and that's our x-intercept. So look at some of these pictures. These are pictures I've kind of collected over the years that represent slope. I want you guys to think about some words that come to mind. I don't know, when I see some of these, I just get kind of tired thinking. Look at these hikers or climbers going up this mountain, this icy, snowy mountain. So we would call this line is going up, right? And if we kind of look at this hill from left to right, it appears to be going down. This roller coaster, this is the part in the beginning where it goes chick, 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 chick. So that's going up. And I'm wondering if some of these look steeper to you than others. Here we have the horizon, kind of a straight line right across. Look at this guy, this poor guy. He doesn't know what's going on. He sees so many different values. There's a little letter here we're going to talk about a lot, M. So all of these pictures, hopefully you've caught on, they are representing slope. And the slope of a line can vary a lot. And you can see in this picture some examples of that. This has an 8% grade. We don't typically talk about slopes in percents, but we're going to talk about grade a little bit when we talk about things like road. We talk about things like roads and driving, especially with these trucks. I'm sure you guys have seen signs like this. All right, so let's get into it a little bit here. All right, so let me see if I can erase this. So we talked about how to find intercepts graphically. Now we're going to talk about how to find slopes graphically. So we just kind of said that the slope represents the steepness of a line. Oops. Yeah, this red guy does not want to go. I don't know if you guys can see that. I wish we were live so you could tell me. So strange. All right, so slope is the steepness of a line, and the letter that we use to represent slope is M. And I know you guys have learned this previously. It's the steepness of a line. There are other things that M represents. Change in y over change in x. Have you guys seen it written like that with the delta? That's a triangle. It's the delta y over delta x. Or you can say change. Change in y over change in x. Ooh, there's another one. You guys might have seen rise over run. That's the one we like to use a lot. So the way to find slope, the way I like to find slope is you start at one point and you try to get to another. So I like to start at the intercepts if I can, just because they're usually pretty good going through the graph points there. So we want to start at -5 and try to get to -4. And you always rise first. Rise meaning up or down. And I know the word rise makes you think up, but if you're up, if you're down, then you're going to rise as well. So this upper part is the y direction. The numerator is the y direction, and the y-axis goes vertically up and down. So from 5, we're going to rise, negative 5, we're going to rise 1, 2, 3, 4 units. And then we're going to run in the x direction. Oops, x. So x is left or right. We're going to go to the right. 1, 2, 3, 4, 5. So we went 4 up and 5 to the right. So we rose 4 and we ran 5. And that is m. That is slope. And it's a positive 4/5. And how do we know that? Because the line is going up. It's very visual. You can see that it's going up, so the slope will be positive. And it is positive, right? Positive 4/5. All right, let's look at this one. Let's start, and you can start at any point on the line that you want and try to get to another point. It doesn't have to be the intercepts. Just if you can, usually that's easier. So I'm going to pick this one and try to get to, I don't know, this one. Why not? The goal is you want to pick a point that is going through a grid mark so you can get an actual value. So I'm going to go, let's say that goes through that grid mark. We're going to go down 1, 2, 3, 4, 5, down 5, and over 1, 2, 3, 4. We went down 5. So going down is going towards the negative number. So it's going to be a negative 5. And we went over to the right 4. To the right are the positive numbers, so it'll be a positive 4 on the bottom. This slope is negative. See? Negative 5. And that's good because when you look at the line from left to right, it is going down. If you were standing on this line, you would fall down the line. So it's negative. So that's just kind of a good way to double check your work there numerically, that it also matches the graph pictorially that is going down. Let's do these. Man, that red line from the other slide is there again. All right, this is a horizontal line, and you might recall from previous years, horizontal lines have special slopes. If you were standing on this line, would you move anywhere? You would only move if you were started to walk, right? But you're kind of just chilling, you're just there. A horizontal line has a slope of 0. There's no change. Remember we talked about the slope being change in y over change in x. There's no change to this line. This line is steady. It is straight across. So this is true for all horizontal lines. All of them. All right, let's look at the next one. This is a vertical line. And vertical lines also have very special slopes. Imagine you were standing on this line. You really couldn't stand on it, right? Think of a vertical slope to a mountainside. Unless you had some really good tools, you would not be able to climb that. I'm talking vertical, like straight up and down, smooth rock. You would probably fall. Hopefully there's a trampoline down there. But vertical lines have what we call an undefined slope. It is undefined. It does not exist. All right, so finding slope algebraically. We looked at it with the graphs, pictorially or graphically. Let's do it with our algebra. So when you're given an equation like this, and we're going to talk about this way more tomorrow, but the slope-intercept form of a line is y equals mx plus b. And I bet you guys remember this from previous years. It's a review. So when it's in that form, you can instantly pull off the slope. There it is. It's negative 5/2. Easy, right? When it's in this form, y equals mx plus b. And I say plus, but this could be plus negative 5. You can write it like that. We could say plus or minus if you wanted to. That's it. Now, when you're given two coordinate points, you have two options. You can graph the points, right? You can plot the points, put them on a graph, and do rise over run, or we can use a formula. We have our formula. Remember, slope is change in y over change in x. So here's the formula. Don't freak out yet. Let me show you how to use it. Whoops. This is y sub 2 minus y sub 1, and x sub 2 minus x sub 1. These little numbers, these subscripts, we call them sub. So y sub 2 minus y sub 1. So let's label the points. We have two coordinate points here. So we're going to label it x1, y1, and x2, y2. There are those values. We're going to find the difference between these 2 points. We're going to find the change. How is the line changing between these 2 points? Which is what we did graphically by counting the change. Now we're going to do it algebraically. So just plug the numbers in. -4 minus, so here's y2, -4 minus 7 over -6 minus -4. It's a subtraction in the formula, so be careful because you're going to have negatives, so this will happen. So this becomes -11, and this becomes -2. So a negative divided by a negative is a positive. The slope is 11 over 2. Let's try this one. I always like to label my points because it just helps me when I go to plug in to the formula. Remember, it's change in y, change meaning the difference. So we subtract the y's and then we divide by the difference of the x's. So we're going to have 15 minus -10 over -15 minus 6. So this is going to be, and you can always use your calculator to simplify this stuff too. 25 over 21, is that right? -21. I'm doing keep, change, flip there. Keep, change, flip. And I believe that stays that, right? They don't have any common factors to reduce, do they? No. So it is 25 over -21. All right, and then the thing we're going to see a little bit later is plotting these and graphing these to confirm our algebraic solution. So it's kind of cool that you can find both the intercepts and the slope two different ways, from the graph or by hand algebraically. Pretty cool. All right, you guys, I will see you tomorrow. Bye, everybody.